row reduction is another way of calculating the value of a determinant. This involves reducing a matrix so that in the top or bottom corners along the main diagonal are zeros, thus the term row reduction. And the idea of this technique is that a determinant is the sum of all signed elementary products. So what this seeks to do is to make all of the signed elementary products zero except for one, the one along the main diagonal. An elementary product of an n by n matrix is the product of n entries, no two of which come from the same row or same column. So none of these come from the same row, same column, same row, same column, same row, same column. They're all in different rows and different columns. So this is an elementary product. By reducing it so that one of these corners is nothing but zeros, it's going to be impossible for any of the other elementary products to be non-zero. So the one along the main diagonal, again, this is the only non-zero product, so the determinant of the matrix is just going to be whatever this elementary product is. A11 times A22 times A33 times A44. This is the only elementary product that's going to be positive. If we try to pick a different elementary product, say same row, same column, so I can't pick any of these ones. Say I pick this one. Can't pick one from the same row or the same column. So looking here at the remaining entries, I've got A43, A44, and then 0 and 0. An elementary product cannot have an entry that's in the same row and same column. So if I pick a non-zero one this time, either one of these, then for the next entry, no matter which one of these I pick, it's going to have to be a 0. And anytime I pick something that's not along the main diagonal with this reduced matrix, it's going to happen to me. If I pick this one, so you can see this column over here has nothing but zeros. Eventually I'm going to have to pick one of them, and then that elementary product is going to be 0. So this is a very fast way of calculating the determinant of a matrix. And an important question, at least for me anyways, is why bother learning all of these different methods of calculating the determinant of a matrix? Sure, it's convenient, but are we really going to be calculating this out by hand? Surely, if I just put it in a computer for anything larger than a 3x3, 4x4, 5x5, won't it just figure it out in 1 second? Well, that's the whole point. Linear algebra is very important to computer science. So if I was to set up a program to calculate the determinant, I could use the sum of all signed elementary products. So for this 4x4, there are going to be 24 signed products, 4 factorial, 4 times 3, 4 times 2, 4 times 1 is 24. Each of these things is going to be an elementary product. 24 elementary products, A1, or whatever, A times 1 times A2 times A3 times A4. Each of them is going to be 4 different things multiplied together. So if I think about it in terms of operations, 1, 2, 3. This is 3 multiplications. So this is 3 operations per, and I'll write it over here. 3 operations per elementary product, and then there are 24 of them. 3 times 24, 72. And then, of course, all of these products need to be added together. So 24 minus 1 is 23, so that's 95 operations that need to be performed to figure out the determinant of this matrix, if I chose not to use row reduction. Now suppose I did reduce this matrix so that there was a triangle of zeros. Let's just say it took, I don't know, 15 operations to get this down to reduced row form. That sounds pretty reasonable. So we'll say it took 15 operations to do that. Now, since all of these other elementary products are going to be 0 except for the one along the main diagonal, then the determinant of this matrix is just A11 times A22 times A33 times A44. So 1, 2, 3. 3 operations. So which one is quicker? This is about 5 times faster than this one over here. So when writing computer programs, this is how computers think. They use linear algebra. Computer science and linear algebra are very intertwined. So you can see that even for computers this is important. A lot of what computer scientists are looking to do is to make computers run faster. So discovering a lot of these shortcuts to reduce the number of processes performed to get the same answer is important, which makes these ways of calculating determinants in anything really in linear algebra. Anytime you're thinking of a science or a branch of mathematics, you need to think of what they're using it for, because doing this stuff by hand, it doesn't really make sense to learn all these different methods. But when you think about it in the terms of what they're really trying to accomplish with this, and in computer science it is about speed, it's about efficiency. So if you make a computer running with this kind of program where it figures out the determinant by row reduction, it's going to be many, many times faster than the computer that's doing it just using the formula.